than hybrids deliver can opt for a vehicle that runs on diesel. Some diesel fuel burns almost as cleanly as gasoline, yet some diesel-powered cars can be up to 30% more fuel efficient than gas-powered cars, meaning they consume less fuel and therefore pollute less. The secret behind this car's powerful diesel engine is a turbocharger. It compresses the air entering the engine's combustion chambers, filling them with a greater quantity of air. The more air, the better the fuel burns, generating extra power. The engine assembly begins with a V-shaped block with 2 sets of 3 cylindrical holes called cylinders. Robots first mount a retaining frame to support the crankshaft. Each cylinder will contain a piston that moves up and down with the combustion cycle. This piston motion will turn the crankshaft, which in turn will move the whole vehicle. But first, a laser beam device owns the cylinders. The laser's heat melts the surface of the inner walls, smoothing them. This ensures the pistons will move with minimal friction. Meanwhile, a robot oils up the crankshaft's main bearings. Then, once the cylinder honing is done, workers install the crankshaft at the bottom of the engine block, locking it in position with the retaining frame. Now they flip the engine block right side up to install the pistons, which are already attached to connecting rods. Once all 6 pistons are in, they turn the engine block upside down again and fasten each connecting rod around the crankshaft. Next, they connect the chain drive to one end of the crankshaft. The chain drive operates camshafts that open and close the valves on top of the cylinders. Those valves are located in these cylinder heads, 4 valves per cylinder, 2 through which air enters the combustion chamber and 2 through which exhaust exits following each combustion cycle. Workers flip the heads upside down and insert long bolts. Then they position the heads over the cylinders, aligning the bolts with holes in the engine block. Robots drive in the bolts to a specific tightness. This caps each cylinder, closing its combustion chamber. Next, workers install a fuel injector into special shafts in each cylinder head. Injectors shoot a specific amount of fuel into the combustion chambers at precisely the right time. These cutting-edge piezo injectors do that multiple times per cycle rather than just once, making the combustion process much smoother. The engine, therefore, is quieter and pollutes less. The next component is the air intake manifold. It goes on top of the engine. Air enters on the left and, as this animation shows, runs to the intake valves on top of the cylinders. It's time to install this engine's secret weapon, the turbocharger. It contains 2 turbine wheels that spin at nearly 200,000 RPM. One turbine compresses air entering the air intake manifold. The other draws out the hot exhaust and sends it out the car's exhaust pipe. The turbocharger sits at the rear of the engine block, in the V between the cylinders. Over at the testing department, technicians analyze the engine's performance, in particular its torque, which determines how much power the engine can produce. Next, the engine goes into a test vehicle, which runs through specific driving cycles that simulate both highway and city conditions, all the while collecting the emissions exiting out the exhaust pipe. This test ensures that the engine meets or exceeds all the emission standards. Not only does a turbocharger give the car better acceleration, it also solves a common problem in high-altitude regions, where decreased atmospheric pressure slows non-turbo engines down. Because turbocharging compresses the air going into the engine, even at high altitudes, the car drives at full power.